Hey guys, today's topic, we're gonna cook a power scaling discussion on something kinda niche but super important, why many worlds interpretation, or multiverse type 3, even with Hilbert space, doesn't equal high hyperversal. Yeah, you heard me right, so let's dive in. MWI breakdown. First, let's break down many worlds interpretation. Imagine a world of infinitely branching quantum outcomes. Each possible outcome is a separate world, branching off from actions. Say an atom can move in 4 directions, right, down, up, left. If in this world it moves right, then the other possibilities, left, up, and down, branch off into separate worlds. Important point, each world isn't superior to the others. Each is independent, existing with its own possibility branch. Scaling and Hilbert space. Now, scaling-wise, MWI hits about 2A at best, even if you include Hilbert space. Hilbert space isn't high 1B, or high hyperversal. Hilbert space is just a math. Quick clarification, 2A is basically infinite separate space-time continuums, while high 1B is infinite dimensionality in spatial or temporal terms. So, what is Hilbert space? LOL, let me explain. Hilbert space is a mathematical tool used in quantum mechanics. Its dimensions or directions represent possible quantum outcomes, not physical space. It's a vector space, directions act like axes, or just ways to move, mathematically. But the purpose of these directions is completely different from actual spatial or temporal dimensions. They represent potential outcomes in the math, like wave functions or superpositions. So it doesn't make sense to just take Hilbert space and call it high hyperversal. In fiction, you might see Hilbert space referenced indirectly, but mostly it's used to handle quantum possibilities. For example, in the Chuhu Project world, Gensikyo is a quantum world with infinite dimensions by necessity, spaces of possibilities. Dimensions are literally mean possible outcomes, not real spatial dimensions. So it scales to 2A, not high 1B. Here are some supporting scans. Those sites weren't just beautiful, but natural too. They were all hidden in the invisible gaps of the quantum world. In the quantum world, things get really, truly wrong. Here we have spaces of infinite dimensions, by necessity. Spaces of possibilities. This is an actual example of Hilbert space in a fictional verse and how it's being used. Honorable mention, someone asked on Quora, how does the infinite dimensional complex valued Hilbert space used in quantum mechanics relate to the spacetime of Einstein and Minkowski? Victor T. Toth, an IT pro and part-time physicist, replied, there is no relationship. Hilbert space is an abstract space representing the possible states of a quantum system. The actual state of a system is a linear combination of eigenstates, forming a basis of this abstract vector space. This space can have a finite or infinite number of dimensions, but it's not related to the dimensions of spacetime. Purely abstract, math-only concept. Basically, a physicist confirmed, Hilbert space dimensions are about possibilities, not real-world dimensions. This destroys the nuance where some might try to call Hilbert space high hyperversal. Also, my friend Axiomatic Refuter, aka Strongest Goku Debunker, supports this. Here's the core of his argument, claiming Hilbert space dimensions are real dimensions is fundamentally mistaken. Dimensions in math equals number of basis vectors to span the space, not actual states or physical directions. Orthogonal vectors equals mathematical independence, not physical separation. Confusing abstract math properties with physical reality equals category error. Infinite dimensional Hilbert space not equal to infinite spatial temporal dimensions. It's just a tool for quantum states. That's it. In short, wave functions, kets, and Hilbert space vectors are mathematical tools, not real entities. Treating them as physical dimensions is like claiming the third harmonic in a Fourier series equals a new universe. Simply, no. Oh, and one last thing, in mathematics, a space is a set, sometimes known as a universe, endowed with a structure defining the relationships among the elements of the set. A subspace is a subset of the parent space which retains the same structure. While modern mathematics uses many types of spaces, such as Euclidean spaces, linear spaces, topological spaces, Hilbert spaces, or probability spaces, it does not define the notion of space itself. Yeah, this destroys any negation based on Hilbert space being high hyperversal LMAO. Conclusion. So after everything, MWI, or Multiverse Type 3, even with Hilbert space, won't automatically grant any verse high hyperversal tier. Without the proper context and requirements for high hyperversal, the best you get is 2A high multiversal. Peace.